Hey everybody, I have gas. Well, let me rephrase that. Let's talk about gas density. So, the idea of gases having density is kind of an old one. It goes back a long ways. But you know, for a long time, people didn't even know the air existed because you don't see it, right? You can feel when it's there, like wind, but it's hard to tell that there's actually something around us. So it took a little while for us to figure that out. And guys like Galileo and Evangelista Torricelli and some of these guys we'll talk about later were the ones that came up with this idea of air actually being matter, being substance. So gases are matter, okay? That means they have a mass and they have a volume. And so remember what density is mass divided by volume. So if gases have both mass and volume, then they must have a density, okay? So gases do have density. And we can measure that density, we can measure the mass and volume and calculate it. But it's a little trickier with gases, okay? The other thing we need to remember about gas densities is that they're very small, okay? Why are they small? Well, gas particles are very spread out. They're not like a solid where they're all packed together, or even a liquid, they're close together. They get to move, but they're close together. Gas particles are zooming around like crazy. They're all over the place, and they're very far apart, right? So that means that if we take a milliliter of gas or a cubic centimeter of gas, there's not a whole lot of particles in there. And since particles themselves are really small, they don't weigh very much. And so the fewer particles means that there's less mass per unit of volume. Okay, so gas densities are very small. That's why we always typically report the density of gases in grams per liter, or sometimes you'll see it in kilograms per cubic meter. We'll figure that one out. Kilograms per cubic meter, okay? Because they're so, the density is normally very small if we report it in grams per cubic centimeter. And then the final thing I want you to understand about gas density is that it's not constant. So if you take a piece of metal, it doesn't matter what size that metal is, but that metal is always going to have the same density because its mass and volume don't change. A piece of metal just sits there. But see, with gases, it's different. Because if you change the temperature of a gas or the pressure of a gas, it changes the volume of the gas. Now, it doesn't change the number of particles, which means the mass is still the same. But if you change the volume of a substance, if its mass isn't changing, and you change the volume, the density is going to change. So the density of gases, when we look them up, they usually have with them a pressure and a temperature, because if you do change those, you get a different value. So usually it's what we call standard pressure, which is 1 atmosphere. It's the pressure at sea level. And usually it's 25 degrees Celsius, which is room temperature. It's called ambient temperature, okay? So usually when you look up densities, like for accepted values of gases, you're going to see the value, and then you're also going to see a pressure and temperature at which that value was measured. It's important, okay? So the real question then is, how the heck do we measure a gas? We can't certainly put it on a balance, right? It's really hard to measure the mass of a gas. The volume of a gas may be a little bit easier. But I want you to think a little bit about it, and we'll talk about it in class. How do we do this physically? Now, you know how to measure the density of a liquid, and you know how to measure the density of a solid. How do you do it with gases? See if you can think of something, okay? See you next time.